Hello guys, how you doing today? My name is once again Dr. Peoples, trying to record a lesson for my class while I'm absent, out on injury. The lesson I'm going to be recording today is going to be how to find the greatest common factor for your rational functions, or I should say rational equations. Alright, the lesson is going to be really solving rational equations, but in order to do that, you first have to be able to find the greatest common factor. So I'm just going to take a couple of rational functions. I have 4 examples, and I'm going to take a little time to show you how you would find the greatest common factor. Alright, the first problem is going to be, I don't know if you can see it that well, so let me do it with the other one. My board. It's going to be 2 over x squared equals x minus 3 over 2x plus 1 over 2x squared. So hopefully you're writing that down or pausing the video. Okay, looking at that problem, the first thing you want to do is ask yourself, looking at the coefficients in your denominator, what is the greatest common factor of your coefficients? Now this problem is easy. You have 2 and 2. That's the only coefficients you have in your denominator. So you can go ahead and write 2. That's the first portion of your greatest common factor. Alright, and once you find the coefficient portion, the next thing you want to do is look at your variables in your denominator. And your variables in your denominator are x squared, x, and x squared. So the next thing you want to do is say to yourself, okay, what's my highest power for my denominators? And you should say x squared. So that makes your GCF for that problem being 2x squared. So that's how you find a GCF for a rational equation such as this problem. Now number 1 will be one of the easiest type problems you can have, and I'll gradually increase the difficulty as we go up to different problems. So that'd be number 1. That's the answer. The greatest common factor for number 1 is 2x squared. Alright, let's go on to number 2 then. Give me a second to write it down. Alright. This will be problem 2. Let me change the camera so you can see it better. Alright, so it's 4 over 3n equals 5 plus 1 over 2n squared. Okay? So looking at number 2, we would do the same process. You have the coefficients in your denominator. You have 3 and 2. Alright, you're trying to find the greatest common factor for 3 and 2. So using your multiplication, you know 3 times 2 gives you 6. And 2 times 3 gives you 6. So that means the greatest common factor between those two would be 6. So that's the first portion of the answer. 6. And then once you get your coefficient portion, the next thing you want to do is look at your exponents in your denominator, the highest exponent. So you have n and you have n squared. So you would correctly say n squared. So for problem number 2, the GCF is going to be 6n squared. And once again, this is a skill we have to have in order to solve a rational equation. So that's why I'm going back trying to review this concept. So that's problem number 2. Alright, let's move on to problem 3. This one will be a little bit different. I might need to erase so I can have more space on my board. Now for problem 3, you have to remember how to factor. In addition to, you won't be just doing a GCF, you got to be able to factor. It's still a rational equation, it's just look a little different. But the skill we're adding now is how to factor. Now if you don't know how to factor, you might need to check out my other video, which I'll be recording in a couple of minutes. how to factor, because that's going to be important also when we're solving rational equations. Alright, I'm writing down the problem. Give me 1 second. Alright, this is problem 3, guys. You have 3 over x squared minus 6x plus 8 plus 1 over b minus 2 equals 2 over b minus 4. Alright, a little glare there. Let me make sure you see that correctly. Alright, so that's problem 3. If you need extra time, just pause the video. But I'm going to go ahead and solve this. Alright, before you can do anything, you notice this problem looks a little different. It has binomials, the b minus 2, the b minus 4 portion. So you can't just look at it and say, what's the coefficient? So it's a little bit different problem. This is the problem we have to know how to factor. So what you want to do is simplify the quadratic. You have x squared minus 6x plus 8. Go ahead and simplify that by factoring. And I'm hoping you remember how to factor. I should have put, oh, my bad, guys. Let me change those variables. I had x's and b's. Sorry, let's change our problem so it can be consistent, because I had x's and b's in the problem. Let's make it b squared minus 6b plus 8. So now we have all one variable, one type of variable. Apologize for that. So we have b's in our problem now. Make that quick change on your paper. Okay. Now back to what I was about to do. Factor in the denominator. So you have b minus 2 and b minus 4. And the only thing we're concerned with is our denominators. The numerator is going to stay unchanged at this point. Okay. Looking at my step, what I did is I factored the quadratic over up under the 3, b squared minus 6x, 6b plus 8. So b squared minus 6b plus 8, I factored that to be b minus 2, b minus 4. And I brought the other binomials down. They already simplified. Alright, at this point, what you want to do is you want to say, okay, what do I see in each part of the problem? Alright, you see b minus 2 in 2 portions of the problem. You see it under 3 and up under 1. And then you see b minus 4 up under the 3 and up under 2. So anything you see repeated, or at least once, you want to say that's part of your GCF. So if you see it once, it has to be part of your GCF. So in this problem, the GCF is b minus 2, b minus 4. And it'll be written like this. Now some people might want to leave it as a quadratic, b squared minus 6b plus 8. But I like to go ahead and simplify it when you find your GCF. You'll see why when I show you how to solve this problem in my next video. Because when you're solving it, you're going to be canceling out numerators and denominators when you do the multiplication portion. So you might want to go ahead and simplify it at this point. Alright, but once again, since we're only finding the GCF, for problem 3, that would be considered your GCF, b minus 2, b minus 4. Alright, so let me do another problem, maybe my last one in this video, problem 4. Give me a second to erase and start this whole process over. Alright, this will be problem 4. Alright, when you look at problem 4, you'll notice that up under the p plus 2, you have a quadratic, you have p squared minus 3p. Up under the two ones, you have a p and a p minus 3. So those are pretty much simplified. Only thing you have to do is factor the quadratic portion, which is p squared minus 3p. Now this is going to be a different type of factoring. I'm going to bring down, let me go ahead and do my work first, and then I'll show you in again how it will look in the second step. Okay, this will be your factoring for that problem. And pretty much what you're doing is you're saying to yourself, okay, it's not like the previous problem where you had 3 terms. You only have 2 terms. You have p squared and you have minus 3p. And both of them have a p. You have a common variable, p. So you want to factor out a p. That's what I did. I factored out a p, and then you're left with p minus 3. And if you recall, you can check that by using distributive property. If you multiply back p times p and then p minus 3p, you see it gives you your original portion of that question, which was p squared minus 3p. Alright? So once you factor out your variable, you should be able to check it by using distributive property. And let me write that over to the right. I do want to show you how to check. You should be able to check this portion. And this is what I'm talking about. You see how I wrote p squared minus 3p? If you distribute back the p, it should equal what you originally had up here where my little star is. Alright. Now, so you have your problem simplified. Let me go ahead and erase this so I don't confuse anybody. You've already factored. Now your question is, what is your GCF? Just like we did in the previous problem, you want to say, anytime you see a particular term or variable in your denominator, you want to write it. So you should see up under the 1, you see a p, and up under the other one, you see a p minus 3. Then up under p plus 2, it repeats. You see a p and then a p minus 3. Now you don't write the repeaters, you just write what you see the first time. So your GCF for this problem would be p parentheses p minus 3. Alright, and once again, it's important that you do not write the repeaters. If you see it twice, you just write it once. Just like I saw p and I saw p parentheses p minus 3, I didn't write p twice. I wrote it once. And p minus 3 repeats as well, so I just wrote it once. And you'll see why when we get to the next step when we start solving these rational equations, but that's the way you would find a GCF for this type problem. Okay, to recap, I showed you 4 problems. The first type problem was the easiest type where you didn't have to factor. All you had to do was look and see what was the coefficient and what's your highest exponent. That was problem 1. Problem 2 was pretty much the same type problem. You had to look and see what was your highest exponent, and you also had to look and find your GCF for your coefficient. The only difference was that you had a 3 and a 2, so it was 6. For number 3, you had to factor. So 3 and 4 were factoring type problems. Now both of them were different types of factoring, but it still was factoring. So for number 3, you had where you had to actually factor by using parentheses. And even though I didn't say it, you can check that by using the FOIL method. You should have learned that in a previous math class, how to use the FOIL method. But you can check it by using the FOIL method. So you factored using parentheses, and you can check by using FOIL. And then problem 4, you had where you had basically 2 terms. Both of them had a p, and you factored out a p. You factored out the same type of variable. And you can check that by using the distributive property. Alright, so this will be the conclusion of my lesson on how to factor. I showed you different, I'm sorry, not how to factor, how to find a GCF for rational functions. Hope to have helped. Once again, this is Dr. Peoples. And if you have any questions, feel free to check out my other videos on YouTube.